Dear students, today's lecture is about Newton's second law of motion. Okay? So, this law is also known as fundamental law of motion because first law and third law can also be derived from this second law of motion, and it gives us the quantitative definition of force. It gives us a way to actually measure the force. Now, what does Newton's second law state? It states rate of change of momentum is directly proportional to an external unbalanced force. Right? Now, suppose this is a car and it is moving with the velocity u. Okay? The car is moving forward with the velocity u. Then, as you know from the definition of momentum, that momentum is the product of mass and velocity. So, a car with mass m moving with velocity of u must have some momentum. That is the total motion contained in the car, and that is initial momentum because the car is already moving with this velocity, right? So initial momentum denoted by pi is equal to mu. Okay? Now, if it is continuously moving with the same velocity u, then we do not need to apply any force. Now, when we talk about change of momentum, right? Now, change of momentum, but what is momentum? Momentum is equal to mv, isn't it? That is product of mass and velocity. So, if we have to change momentum, right? So, we have to change either m or v. But till class 9 and 10, we do not talk about the changing of mass. So, we will be concentrating on change in velocity. And in the previous videos, I have told you that velocity can change only when an unbalanced force is applied. Because under the action of unbalanced force only there is an acceleration, right? Because the resultant is non-zero. So if it is moving with u, it will go on moving. No force is required because it is in uniform motion. If we want that its velocity should change from u to v, then we do have to apply an external unbalanced force, let us say F. Okay? Now what did F do? F changed the velocity. Right? Now when force changed the velocity, then it automatically changed the momentum, isn't it? So, if initial momentum is this, that is before we have applied an external unbalanced force, and after the application of force, the final momentum has become mv, right? So, what is change in momentum? Delta p. Change is denoted by delta. P is momentum. So, change in momentum delta p is equal to final momentum minus initial momentum, right? Now, brought by force. Okay? So, can we substitute the values of final and initial momentum over here? If we can, then delta p becomes mv minus mu. When we talk about rate of change of momentum, So change of momentum is not directly proportional to an unbalanced force. It is the rate of change of momentum. So rate means change in momentum, okay, divided by time. So rate of change of momentum will be delta P upon T. So now we can say that Newton's second law states force is directly proportional to rate of change of momentum. Okay? But here it is the sign of proportionality. It doesn't say that it is equivalent. Okay? Proportional means that if there is more change in momentum, force will be more because there is direct proportion. Force is directly proportional to change in momentum. But with time it is in inverse proportion. That is, more the time, less the force. But nowhere it says that force is equal to change of momentum. If we have to change sign of proportionality with the sign of equality, then we use a constant k. So then our formula or our equation becomes F is equal to k, constant of proportionality, multiplied by rate of change of momentum. Okay? Now, if we bring it here, can we substitute delta P with mv minus mu upon T? Okay? Then, after substituting, we take m common. Then we get F, that is force, is equal to k m whole multiplied by v minus u divided by T. Okay? So, when we look at this, don't you think this is acceleration according to first equation of motion? So, instead of v minus u upon T, we can write F is equal to k m multiplied by a. Now, if a force of only 1 Newton is acting on this and its mass is 1 kg and it accelerates by how much? 1 meter per square second. So if that thing happens, that F is equal to 1, M is equal to 1, K is equal to 1, then what happens? Then K is automatically equal to 1, isn't it? Now, anything multiplied by 1 remains the same. So, in this formula, F is equal to KMA. We can neglect K and we can write F is equal to MA. That is, force is equal to mass into acceleration. Now, instead of acceleration, we can always write V minus U upon T, and then we again come to the conclusion that force is directly proportional to change in momentum but inversely proportional to time. It means more is the time, less is the force. That is why a fielder is told not to catch the ball like this but to bring his or her hands down. Because when the catch is taken at this position, time increases and impact of the force on the hands decreases. So it is more convenient, right? And if a karate player has to break a large, slab of ice, very thick slab of ice, then he has to apply force for a very short duration of time. Because if time is less, then force will be more. One more thing. Momentum, rate of change of momentum is equal to delta P upon T, right? That is, more the time, less is the change in momentum, right? So it again comes to that. So less the time, more the force, more the time, less the force. This concept is used that when a person is to jump, then he should jump on a spongy thing or directly a hard concrete floor. So it is the impact of force. If there is, a hard floor on which you have to jump down, okay? This is the person and he has to fall on concrete floor. And this is the person who has to jump and fall on a trampoline. Okay? Now this is having an initial momentum. This is also having initial momentum. When it comes here, then V becomes 0 immediately in a very short duration of time. So, the rate of change of momentum delta P upon T is very large. So, very large means rate of change of momentum is equal to force. That a very large force will act on this person. Whereas when this person falls here, then it gets compressed, okay, trampoline, and then the time when it comes to rest increases. So when time increases, impact decreases. So that is the reason we pack our things in thermocol or bubble wrap. Okay? Now what is impulse? Impulse is a force acting for a very short duration of time. It is F into T. So F into T is equal to mv minus u. So force acting for a very short duration of time is called impulse and its units are Newton seconds. Thank you so much.